Welcome back, everybody. So let's see what we got. So yes, so people pretty much got this down pretty well, right? 1, 5, 10, or 20. And if you picked a $1 bill, you can only pick a 5, 10, or 20 for your next one. Pick a $5 bill, you can only pick a 10, or a 20 for your next one. So these change depending upon what you pick first. And then here is your set of possible outcomes, your sample space. And they notice that n is 12, so they're noting that there's 12 possibilities. Great. All right, excellent. So a lot of you guys, did a nice job of this. So well done. All right, excellent. Now we're going to talk about the addition rules for probability. So how about Hanan? I haven't heard from you today.
Addition rules for probabilities. Two events are mutually exclusive events or disjoint events if it is impossible for them to occur simultaneously. Exclusive means separate. Additional rules. So P of A.
Probability of
A or B is equal to the probability of A plus the probability of B. That's mutually exclusive. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Not mutually exclusive.
Okay, great. I'm going to hop in for a quick second here. Right, so these are the ones we did earlier, right? If it's like the probability of being a boy puppy or male puppy or a female puppy, right? There's no overlap. Or being a chocolate lab or a yellow lab, you can't be both. You can only be one or the other. Those are mutually exclusive, so you just add their probabilities. But remember when we had like a chocolate or a female lab? We had to subtract the overlap. That's this probability of A and B. It's the people who are in both groups. So that's the overlap we're subtracting, is this probability of A or B. So when they have overlap, right, like a female lab and a chocolate lab, then we're going to subtract out their overlap, the female chocolate labs, because they're getting counted twice. Great, keep going, Nan.
It refers to the same occurrence. Same roll of dice, same person selected, same card. Why does it have to? Hint, consider 3 flips of a coin.
Right, because what if I said, well, it's probably I get a heads on the first one or the second one or the third one. They don't look at those separately, right? It's you can't say, oh, well, 1/2 chance and 1/2 chance plus 1/2 chance is 150% chance that I'm going to get a heads if I flip a coin 3 times. That's not true. It's got to be the same event. One probability experiment. That's what I'm trying to say. Okay, good. We'll worry about this one later. All right, so I want to take a look at these ones here. Take 30 seconds and decide, actually take a look at the first one. Decide if the first one, male or chocolate, is mutually exclusive or not mutually exclusive. Or mutually exclusive means they have nothing, they have no overlap, nothing in common. Male or chocolate, does that have any overlap? Yeah, it does, right. So you could be a male chocolate lab, which means that they are not mutually exclusive. Not. M-E. How about the next one? Black or yellow? Yeah, those are mutually exclusive. There's no overlap. You cannot be a black lab and a yellow lab at the same time. So those are exclusive. Exclusive meaning they have nothing in common. How about female or black? Can you be a female lab and a black lab? Yes, you can. So that means they're not mutually exclusive. They have overlap. And how about yellow and female? Everybody private chat that one to me. Private chat it. mutually exclusive or not. Good. Most of you guys are getting it. They are not mutually exclusive because you can be both. Yellow, female labs, right there. Okay, great. I think this is in your notes. Is it in your notes? Maybe it's not in your notes. It might not be. Okay, no. It's not your notes. You're like, Okay. All right. No worries. All right. So then this is not. I think this is also not in your notes. Is this in your notes? Oh, it is. Okay, good. Great. This is important. The difference between or and. People get confused with these all the time. So or is the union between two things. So that means that you are a female lab or a chocolate lab. Either one is good. I like to think of this as like a little guy standing and his little arms are upraised and he's like upping his arms up. He's like, oh, I take all of you, right? I take, it's the union. So he's like, oh, I take, how do I get me? I need to do, sorry. I take you, and I take you, I take all of you, right? He's got these arms outstretched and open and taking everybody. That's the or. All right, that's this one here. The and, I like to think of it like, no, I can't stand up on my chair, that's not going to work. But I like to think of it as a bow-legged cowboy. So, here's the bow-legged cowboy. He's got one leg in A, one leg in B. He is in both. So that's how I remember the and. He's in both. He has one leg in one. He's got one leg in the other one. He is in both groups. That's the and is the intersection. You have to be in both. Let me show you the pictures, the graphs, the Venn diagrams for these. So for and for the intersection, it's just this part here, just the part that's in both of them. For the or, you can be in this group, or you can be in that group, or in both. You're all welcome. Right? So this is everybody. But we have to subtract out if you count, still got a little bit confused with this earlier. If you're counting all of this, and then you're adding in all of that, then the middle part is getting added twice. So you have to subtract off one of them, so you only count it once. But the union is all of that. Make sure people are clear on what these represent. Okay, good deal. Okay, so then next, I want you guys to do a lab problem 11. It's not on a Jamboard, so I want you guys individually to take, I don't know, maybe, if you want to be in your breakout rooms, I'll let you guys talk about it, but I don't have the Jamboard up for it. You know what, we're not going to take the time to do that. We're just going to jump into it. So a king or a queen or a jack. So let me grab our notes. We are right here. King or a queen or a jack. Make it a little bit bigger. What's the probability that I get a queen or a king or a queen or a jack? So everybody write it down. What do you think? So let's see. Here are the kings. Here are the queens. Here are the jacks. So what do you guys come up with? Looks like there are 12 of them out of how many? 52. It says at the top, 52 playing cards. I have 52. That's the top one. Now, the next one is, what's the probability that is a heart or a club or a heart or a diamond? So here are the clubs. Here are the hearts. Here are the spades. So it looks to me like there's no overlap between these guys. So there are 13, 26, 39 out of 52. Now it gets a little bit more complicated. Now we're saying a king or a queen or a diamond. King or queen or a diamond. So let's see. Here are my kings. Here are my queens. They don't overlap. That's all good. But then here are my diamonds. All of a sudden there's some overlap. So let's see. The queens, there are 4 of them. Kings is 4 of them. Diamonds is 13 of them. However, these 2 here are in both groups. There's overlap. So it means I need to subtract off 2 of them because I'm counting them twice. They're getting counted in the 4 total and they're getting counted in the 13 total. So it's going to be 4 plus 14, 4 plus 4 plus 13, my bad, minus the 2 that are being double counted out of 52. So we'll end up with 11, 19, I think. 19 out of 52. Good. Good. Questions? Okay. All right. I guess it's a no. All right. I'm going to show you guys another drawing for this. Okay. Here we go. So here it is. Did we skip stuff? No. Huh. Wow. I don't know how we got through this. The class is way behind. Good deal. Okay. So let me show you what it looks like in terms of the tools here. So kings, I have 4 kings. 3 of them are not a diamond. 1 of them is a diamond. Queens, I have 4 of them. 3 of them are not a diamond. 1 of them is a diamond. And then the diamonds, I have 13 of them. 1's a king, 1's a queen, and 11 are neither. Make sense? So these are the things I should add up. 3 plus 1 plus 11 plus 1 plus 3. If I add up the totals, if I added up, the 4 plus the 13 plus the 4 here, then I'd have to subtract off these. I'd have to subtract off the overlaps. Because they're being counted twice. They're being counted in this 4 and they're also being counted in the 13. Okay. Now, are there questions about your homework? People had homework questions, I think. Are there homework questions? Are there lab questions? Let me talk about a couple things. One is, if you are if you're having trouble with Excel, because everybody, again, reminder, You can get Office 365 for free. But if you're having trouble with your Zone Mail, like you don't know how to access your Zone Mail, you're unable to access it in Canvas, if you go to at the bottom of our homepage is this LPC Fall 2020 page, and this has a lot of different services in there. One of them is the Computer Center. And these guys can help you. They're there Monday through Thursday, 8 to 8. Wow, that's a lot. Fridays, 8:30 to 3. And you can drop in help, and they will help you. You click on this. I can't do a Zoom meeting while I'm in the Zoom meeting. But, you can hop into a Zoom meeting, and they're there to give you guys help, and they can help get you hooked up with your Confer Zoom, and they can also probably walk you through getting Office 365 installed as well. Again, if you are using Google Sheets, you need to save it as an Excel file and download it, and then you can upload it to our Canvas for your assignments. Are there really no homework questions? People had some homework questions, I thought, last class, so I thought maybe you guys might have some as well. No? None at all?
Professor Young?
Yeah.
In math problem 10, I was just wondering, what exactly are you looking for? You're looking for, so the tree diagram, of course. I'm talking about the $1, $5, $10,
Yep.
$20.
I want the tree diagram and the sample space. So I want this. This is exactly what I want.
Okay.
Give me the tree diagram, and then give me the sample space.
Okay.
Yeah. Good question. All right. So let's go ahead and move on. Next, I want to talk about, I'll stop here for a second. Okay, so I'm going to take a quick break. I want to talk about two things. One is, you know what, I'll do it at the end of class. That's okay. Let's do this. It's easiest to do it at the end of class. All right, so now we're going to talk about multiplication rules and conditional probability. So two events A and B are independent events if the fact that A occurs does not affect the probability of B occurring. So in other words, you know that A has happened. Does that affect the probability of B happening? All right, so here's an example. Does drawing a heart, so here, what's the probability you draw a king? What's the probability I have these cards, what's the probability I draw a king?
4 out of 52.
4 kings, right? Out of 52, so 4 out of 52. And if I simplify that, it'll end up being 1 out of 13. I'm going to draw this a little bit tighter. 1 out of 13. Simplified. Great. Now, I'm going to change it a little bit. I'm going to tell you, okay, I've drawn a card. All right, guys, I'm looking at my card. It's a heart. I am telling you this card is a heart. Now you know it's a heart. You know it's not any of these guys. You know it's not any of these guys. You know it's not any of these guys. It's definitely one of these. Everybody on board with me? I'm giving you the information that's a king. I'm telling you it's a king. Now, sorry, I'm giving you the information that's a heart. I'm telling you that it's a heart. Now what's the probability that's a king? 1 out of 13. So I would write this as the probability of getting a king given, remember given this long line, given it's a heart. Well, if you know it's a heart, that probability is 1 out of 13. Does that change from my original probability of getting a king? No, it's the same. These two things are the same. Because they're the same, then it doesn't matter whether I know it's a heart or not. It doesn't help me at all. It makes no difference. So that means that they are independent. King is independent of heart. Does that make sense for folks? Well, you might be like, well, give me an example of something that where it's not independent. Okay, I can do that. All right, so here's my deck of cards. Let me find it. Where is it? Here it is. All right, here's my deck of cards. Deck of cards. Here is my King of Hearts. Everyone see it? I'm going to throw it away. It's gone. It's on the floor over there. All right, fine. Now, I'm going to draw a card. I draw a card, and I tell you, oh, the card I've drawn is a heart. This card is a heart. What's the probability now that it's a king? Anyone? This is my deck. This is my deck now. I've taken the King of Hearts and I've thrown it away. I've checked it. It's laying over there on the floor. Now, out of this group, these group of cards, I draw a card and I tell you, this card is a heart. So much better in person. Okay. What is the probability? It's one of these cards here. What's the probability it's a king? Zero. Totally. Right? So the probability it's a king is 0. So now, knowing that it's a heart gives you information. What's the probability of a king normally with this deck? 3 out of, let's see, 3 out of 51. That's the probability of king. With my revised deck with my poor little King of Hearts sitting on the floor over there in the corner. But now, the probability of king, given it's a heart, is now 0. It's changed. So knowing it's a heart is very helpful. Now I can say for sure, it is not a king. That is dependent. It's changed the probability. It's gone from 3 out of 51, right, like 6% to 0% chance. So these are dependent because knowing it's a heart gives me some information. It changes the probability. It's not the same probability. It doesn't have to be 0. It could have been like 1 out of 51, but it's not the same. It's different somehow. That's what we mean by saying that they're dependent. The probabilities are not the same. They've changed. The way that my probability instructor explained it that made sense to me was he said, knowing it's a heart gives you information on whether or not it's a king. It gives you some information. It changes your guess. Before I would have guessed 1 out of 17, 3 out of 51. Right now I'm going to guess a smaller likelihood. Oh, I really wish I could do this. All right. We'll try. Where'd my 4 hearts go? Here it is. Okay. I don't know if you guys can see this. Okay. Here are 5 cards. 5 cards. Everyone good with that? Ace through 5. I'm going to mix them up. I'm going to have Colleen, choose one. First, second, third, fourth, or fifth. Choose one.
The second one.
Second, this one. All right, Colleen chose this one. All right. Now, what's the probability she chose an ace? Guys, what's the probability she chose an ace?
1/5.
Yeah, 1/5. 1/5 chance she chose an ace. We're going to put it back. I'm going to mix them up again. She did not, by the way. That's okay. And I'm going to have Jamila pick a card. What's the probability Jamila picks an ace? She's going to pick card number 2. What's the probability that Jamila picked an ace? Also 1/5. The same, right? Now, I'm going to put the card down, and I'm going to have somebody else. Ulysses, pick a card.
Put a card or just...
Sure, one of these. One of the ones I'm holding.
Third one.
Third one. All right, he's going to pick what's the probability that he's picked an ace?
1 in 4.
1 in 4, or it could be 0 in 4, depending on how much one she picked. But it's not the same. It's not 1/5 anymore. Do you guys see that? It's no longer 1/5. The probability has changed. So that's dependent. That is what we call dependent. The probability is not the same anymore. It's different. The probability before was 1/5 of drawing an ace. Now it's 1/4. So with replacement means that there is the probabilities stay the same and they're independent. If you do not replace them, then they are dependent. So without replacement is dependent. With replacement is independent. So before with these ones over here, these guys, we did not replace them. So these are dependent. Do you guys see that? We didn't replace the cards in between, the bills in between. So the probabilities are not the same. Okay. Now, I'm going to flip a coin, and I'm going to roll a die. I don't have a coin on me. I need a coin. Really? You'd think I'd have a coin somewhere. That'd be so useful. Maybe I do. All right. Oh, that's okay. I'm going to flip a credit card. I'm going to roll a coin. Or not roll a coin. All right. So here is here's the credit card. I'm going to flip it up in the air. It's either going to line up on heads or tails. And I'm going to roll my die. What's the probability that I roll a 4? What's the probability I roll a 4, guys? 1 out of 6. Great. Now, here's the thing. I'm going to toss up my credit card. It came up tails. My credit card is tails. Now what's the probability I roll a 4? Still 1 out of 6. Is flipping this credit card and rolling this die, are they independent or dependent? Independent, because no matter what I flipped here, it didn't matter. I still had a 1 in 6 chance of rolling a 4. Do you guys understand that? Those are independent. What happens here does not affect what happens here. The probability of this happening. They have no effect upon each other. Independent. Okay, good. So let me ask you some questions here. Lab number 12. Are these independent or dependent? So, chocolate and male. Does knowing it's male, so you guys need to pay attention. These next 10 minutes are really important. This is a hard concept. It's not a hard concept. It's a little bit of a hard concept. If you pay attention, then it'll be less. It'll go much smoother. Okay. Does knowing it's male give you any information about whether it's chocolate? So here I don't know what it is. I have no information whether it's chocolate or not, or male or not. So what's the probability I get a chocolate lab? There's 20 total. So this should be 8 out of 20? Yeah?
Yes.
Okay, great. 8 out of 20. Oops. 8 out of 20. Great. Now, given it's male, means that I know it's a male lab. It's a male puppy. Now what's the probability that I get a chocolate lab?
6 out of 20.
6 out of, almost 6 out of
12.
Because I know it's not any of these, right? It's only these.
Wow.
Good. Excellent. So, yeah. So, now remember, given changes my total. Now it's out of 12, so this is, thank you for it's almost like I planted that. I needed that in there. So, 6 out of 12. Are these the same? So, this one ends up being 0.4. This one equals a half. Those are not the same. So now I know that I have a little greater chance of picking a male puppy if I know it's a chocolate lab. Please note, this only applies to this sample of puppies. I'm not talking about all puppies. I'm not talking about whether being a chocolate lab affects whether or not you're a male puppy or vice versa in the world. I'm talking just from this sample. So when I'm doing these questions on the exam, this applies, when I ask these questions, it applies to just this sample. So don't go telling me, well, you know, whether or not you're, you know, you like tea doesn't affect whether or not you're male or not. I don't care about the world. I'm talking about just this sample, just the samples I'm talking about. So in this sample, I know if it's a male puppy, that it's more likely it's a chocolate lab, because half of them are chocolate labs. Okay, so far? So here is an easier way of thinking about it. What are the things that have to do with chocolate and male? Oh no, chocolate and male are independent or dependent. So which of these numbers here have to do with chocolate and male? I'll put in the total here. I'm going to give you one. What's one thing that has, what's one of these terms has to do with, one of these numbers has to do with chocolate or male? So Hale, give me one, just one.
I don't understand the question.
Which one of these numbers, does this number have anything to do with the chocolate or chocolate male?
No.
No. Give me a number that does.
6.
6. This one here?
Yep.
Yep, because that's the chocolate male labs. Now, what else has to do with chocolate or male, kind of specifically, but nothing else? And we have another guess?
8.
8. Why? It's my total chocolates, right? Good. Somebody give me another one. Alay or Jacob, can you give me another one?
12.
12? Yep,
Yeah.
my total number of males, that's good enough. And then the grand total. So when you think chocolate and male, these are the three things that come to mind: the total chocolates, the total males, the chocolate males, and then the grand total. Now, make those into fractions. Is 6 over, well, you could do it either way. I can do a fraction this way or the other way. Is 6 over 8 equal to 12 over 20? And that answer would be no. So they are dependent. You could also go the other way. You could also say, maybe I'll do this in a smaller pen so we have more room, is 6 out of 12, right? 6 over 12, the same as 8 over 20, which is exactly what you guys found. Those are the numbers we found down here. You're probably chocolate and probably chocolate given male. Are those the same? And we found that no, they're not. Right? So again, either So you can, it's a ratio, so you can look at this ratio over that ratio and see if it's the same as this one over that one. Or you can go the other way, 6 over 12 is not the same as 8 over 20. If they're either going to both be exactly the same or they're both going to be not the same. If they're not the same, they're dependent. If they're the same, they're independent. Let me show you another one. So how about this one? Are these independent or dependent? And I'm hoping that I was smart enough to put this on your sheet. Any notes? Anybody help me out here?
Yeah.
Okay.
Bottom of the yellow.
Right, that was the first one. Oh, this is the second one. Same one. Yep. So now female and yellow. Same picture above. Same table. What do you guys think? Find the probability it's female. Find the probability it's female given yellow. So again, these are the same thing. They're both probability it's female. It's just one is given nothing, probability female given nothing, and one's probability female given is yellow. Find those two probabilities and see if they're equal. You guys know how to do that. You did that in your quiz earlier today. Find the probability of female. Find the probability of female given yellow. All right. Let's see. What's the probability that they're female? Probability of female is 8 out of 20. So that is 0.4. Now, given it's a yellow lab, let's see. I know it's a yellow lab. This group here. Now it's probably it's female. 4 out of 6. That's much more likely, 0.67. So that's totally, these are not the same probabilities, right? So this is dependent. I should probably use a different color. Dependent. And again, you can look at the ratios instead. If I wanted to, I could just look at the ratios. This is 20. I could grab, I want female yellows. Which of the ones have to do with the female or yellow lab? Someone give me one. Trevor, give me one. Female yellow. Trevor? How about Olivia? Give me one.
A number that relates to the
To female or yellow?
4.
4? Female yellow. Good. Dylan, give me another one. Dylan, Alex, Dylan A. Okay. How about Constantine? Should we do female or yellow? Yeah.
Female or yellow?
Yeah.
So what's the question exactly? Just how that point.
Which of these numbers has something to do with female or yellow?
Oh, I guess 2.
2?
Sure, yeah.
This one has to do with this has to do with males, not females.
No, not the female on the black side. Is that?
Female or yellow? No. That has to do with black. That has nothing to do with that. That can't be right either, because that has to do with...
I'm sorry. Is it 8 then?
Okay, 8. Yeah, that works. Because that's the total females. All right. Someone else, another one. How about Eddie?
6.
6. total yellows. Now, 4 out of 8, I can do, so I can either one. I can either do 4 over 6 compared to 8 out of 20. That's these two numbers here that we just did, right? Or you can do it the other way. You can say 4 over 8 and 6 over 20. And like I said before, either they're going to both be either these two proportions will be, doesn't matter which direction you go, either both going to be equal or they're both going to be not equal. In this case, they're not equal, right? 4 over 6 is not equal to 8 over 20. Does that make sense for folks? 4 over 6, I'm going to compare 4 over 6 to 8 over 20 and see if they're the same. So just divide them, right? Get a whole bunch of decimals, give yourself 3 or 4 decimal places, and see if they're the same. And again, you're going to see that they are dependent. They're not the same. Because the proportions change when you know it's yellow. Okay, now let's look at another one. Okay, so find the probability of female. This is a different one. This is your next page, the very next page. We're over here. So find the probability of female. Find the probability of female given chocolate. Oh yeah, this is a great thing, right? So here's a great clue that one of my students pointed out. She said, female given chocolate looks kind of like female divided by chocolate. Do you guys see that? It looks a lot like this sort of division sign. So that means you're going to divide, when you have female given chocolate, you're going to divide by the number of chocolates. That means I'm going to divide by the total, I'm going to divide by 8. Because that's my total for chocolate. So that's the thing that, that kind of helps her remember, and it helps a lot of people remember which one you divide by. Female given chocolate means you divide by the total chocolate labs you have. All right, so go ahead and find those. Dylan, I'm going to ask you for one. And who is the other person who didn't respond to me? Where they're gone. And Adriana, I'm going to ask you for one. So Dylan, find the probability of female. And Adriana, find the probability of female given chocolate, and type those into me. Good. All right, so probability of female is 15 out of 40. Great, because the total is 40. Put the 40 in there. Equals 15 out of 40. And then, Adriana, did you get the probability of female given chocolate? Yeah, 3 out of 8. That's given chocolate, 3 out of 8. Now, I don't know if those are the same or not. It's hard to tell, so I'm going to put both of them in my calculator. And when I do, I'm going to end up getting 0.375 for both of them. So in this case, they are independent. I think I'm just going to type that. These guys are independent. Because these ratios are the same. I could also grab them, right? Grab the ratios, the 3, the 8, the 15, and the 40, right? Total females, total chocolate, female chocolates, and total, and do 3 over 8 compared to 15 over 40. They are the same. So 15 over 8, sorry, 15 over 40 and 3 over 8. Since those probabilities are the same, then it is independent. That's the easiest way to check for independence. Okay, good. Questions about this one before we go on? All right. So here is our kind of the final thing we're going to be doing. Yep, final thing we're going to do today. Let's get a reader. How about Grace? Go ahead and read for us.
The multiplication rules and conditional probability. Do you want me to say the?
Yeah, please.
Conditional? Okay, multiplication rules. The probability of A and B is equal to the probability of A times the probability of B. And that is independent.
Great. Nicely done.
And the probability of A and B is equal to the probability of A times the probability of B given A.
Nice.
Dependent.
Excellent. Perfect.
And then the conditional, is that it?
No, keep going. That's great.
Okay, keep going. Okay, the conditional probability of
Probability.
probability of B given A means the probability of B given A, given that A has happened under the condition that A has happened.
Perfect. Nicely done. Well done. Right. So here, if they're independent, we just multiply the probabilities. If they're dependent, they take the first probability and then multiply it by the probability of the second one, given the first one has happened. So that means this one was dependent. If I want to find the probability that I pick a chocolate male lab, right? I want to know the probability. First of all, if I'm doing this, I could just probability of chocolate male and male. I could just find it, right? What is it? It's 6 out of 20. But if I want to do it by multiplying, then I'd have to grab the right ones. I'd have to take the probability of chocolate. Let's see, that's 8 out of 20. So this would be probability of chocolate times the probability of male given chocolate. So that would be, let's see, what's the probability of chocolate? Probability of chocolate is 8 out of 20. I'm going to do this by hand, so it's easier to write. Fraction 8 out of 20. And then male given chocolate. So given chocolate is male is 6 out of 8. And what you're going to find when you do that is that these guys, these two things, are always going to cancel. This one here and this one here are always going to cancel. And then you're going to end up very nicely with 6 out of 20, which is what you expect to get. Just from looking at the table, what we got up here. Good. All right, oh, shoot. I have one last thing to talk about, and that is this. Every once in a while, I'll try to think of like one thing or two things or three things that I want to talk about. I was going to think of two things, but I really only have one thing. It's really down to one thing. So this is important stuff that is, about life, not about just math, because, it's not just all about math. It's also about life and everything else. And that is, we just had our Classified Appreciation Day yesterday. It was really great. We had a chance to thank all of the classified staff for helping out, faculty and administration for all the great things they do. And you get busy with life, and you forget to do that just because you ran out of time and things are crazy and nuts. So it was really nice we got a chance to thank them, and they were really appreciative, and we felt good about it, they felt good about it, everyone felt good about it, right? And I think in life we just forget to do that. So, if you're in the store, like obviously not during COVID times, but like generally speaking, if you're in the store and the person's doing the checker's doing a really good, efficient job, just say, hey, you're doing a great job, I really appreciate it, or, I love the fact that you're super friendly, or whatever, to a stranger. And also to your friends, because we forget to tell each other how the things we like about each other. Like we forget to compliment each other, right? Or thank each other for, for your friend for being a good listener or whatever it is. So like this weekend I have, I'm hanging out with my friends, and I think I'm going to take a minute and just thank them for the things I really like about them, and let them know how much I appreciate them, and you know, there are really great, unique things about them that are really good. Because we all just need to hear that once in a while. We forget, we don't also realize what other people think of us. Like, you know, we kind of bob along and we don't really see ourselves as other people see us. And it's kind of nice to get this, you know, it builds your confidence, kind of hear about, like, the good things that other people think about you. You know, so just try to, like, you know, do that in life. Just try to, like, tell your friends or tell people that, you know, just say it. Just, it doesn't cost you anything to tell people the good things you think about them. So just try to remember to do that, because it doesn't cost you anything and just puts more good energy out in the world, right? And more positive, you know, positiveness. All right, so that is it. That is my one thing for today. Have a great day, and I will see you guys. Have a wonderful weekend, and we'll see you on Tuesday. Oh, one more thing. The things you're turning in today is page 10 from your notes, and the first page of your quiz that we did today, 4.1 quiz today. So those are the two things you're uploading. Have a wonderful weekend, and we'll see you on Tuesday. Thanks. Bye, everybody.
Is it page 10 or page 12?
Page 10. Yeah, because we did not get to 12. We did not really get to finish 12. So, or the other class didn't get to finish 12, so I'm just going to do 10.